But first, I would like to at least have a sense of how many of you are neuroscientists. Please raise your hand. How many of you are computer scientists? Philosophers? Mathematicians? All of the above? One person. Okay. All right. It's good to know. All right. So at least I have a vague sense of that. Doesn't mean too much these days, since we are sort of all in between fields. I got a little bit of feedback from Matteo telling me that while I wanted this to be a fully interactive day, it would indeed be appropriate to start a little bit with the basics of IIT that apparently has been discussed a little bit in the papers have been looked at. And so I'll take that opportunity. But even so, I really want to emphasize that you should feel free to interrupt and say, this is not at all clear to me, or I completely disagree, or what are you talking about? You can do that. I'll take care of it, meaning we're not going to be bogged down if that's what happens. Okay, we'll go forward, but we will really play it a little bit by ear. And I see several friendly faces. I think we can now start because Masahumi is here. I saw him come in. It's been a long time. Hello, sir. Okay. And I want to start with this, which is usually the biggest problem there is for people to understand IIT. And that is the extrinsic perspective as opposed to IIT's intrinsic perspective. And I think most of us, and certainly most of the people who are supposedly in the field, if there is such a thing in conscience, the people you would see at the ASSC, are prisoners of this perspective, which is a very natural one, okay? It is the perspective that we all learn since we were born, in a way, and that is the classical naive realism. There is a world out there. There are objects and people and bodies and animals and plants and so on and so forth. And then it gets refined by science, which we all study, such that we understand that it's not as simple. In fact, the world is much more complicated and subtle than we think. There were the articles today about dark energy again, so we still don't know a lot about lots of things. But when it comes to biology, for instance, and the body and the brain, while we like to say about the brain being the most complex organ in the universe and being very mysterious, the mystery, in a way, is not really there anymore, I think, to a large extent, to all of us who take the extrinsic perspective. It's a complicated biological machine. It's made of neurons, we know that, and all kinds of molecules and these circuits. Yes, it's complicated. But really, if you look at it from the perspective of somebody who is trying to do, let's say, large language models, well, it's going the other way around these days. We're not starting from the brain and have some insight about how to build neural networks that then could do fancy things. It's actually going the other way around. Now we look at what neural networks can do, basically LLMs, and then move it back and see, look, the brain is probably doing something like that. And now we understand a little bit better why we can do the things we do. So it's becoming like a badly implemented LLM, our brain, with lots of, trade-offs you have to make for biology, issues about energy, then it's dirty and unclean. Yes, we can still celebrate the fact that it self-heals to some extent, not very much. On the other hand, it ages. All kinds of problems in the brain for performing those functions that now they are jumping at us can be performed much more efficiently by other LLMs. But if you look at it like this, there's really nothing that is so special about the brain in terms of the computations that it performs. It's an endless game. In cognitive neuroscience, for instance, people are running an immense number of experiments to find out what lights up and what you can decode when you do X, Y, and Z and invent new paradigms and do it more ecologically or less ecologically. You do all of these things, and you end up figuring out that the brain is a very complicated machine that does very complicated things, not unlike what LLM, after all, do. Or since I mentioned this morning on the way here, not unlike what VLAMs are or will be doing, where VLAMs are vision, language, action, models, basically robots with an LLM brain. Okay, they are growing all around us, perhaps even more in Japan, who knows? And what is really different? And so if you take the extrinsic perspective, in which there is a world out there which is now described by whatever our best physics is telling us, which is the usual way of philosophers to put it, okay, mass, charge, and who knows, quantum fields. Then there are, biological organisms, which are complicated but mechanistic. Then there are bodies, then there are brains, and brains do all kinds of things, like VLANs. One of the things they do is this mysterious thing called consciousness, which is a mystery we should really dispel. So that's the attitude. And so I call it the cherry on the cake approach to consciousness. We are figuring out how the physical world works. The biggest mysteries are really fundamental physics. But then at the end, we end up with the brain, which is a complicated machine, a VLAM of some sort. And then it also does consciousness. And that's, of course, the source of the so-called hard problem, etc. That it seems, all right, it does consciousness, but there seems to be this big gap that we cannot bridge. And the truth is, we cannot, if we take the extrinsic perspective. If we think that the secret to consciousness, assuming, and you wouldn't be here probably if you didn't think so, that it is indeed important and you take it seriously and there is something there that needs to be explained, assuming that that can be explained purely by looking how the machine does X. So how does it do episodic memory? How does it do working memory? How does it do object recognition? Okay, we can answer those questions. And then how does it do consciousness? And the vast majority of people among the experts these days think that it does consciousness. Well, consciousness is some kind of fancy computation or function. And they disagree on which computation, which function it is, but that's the attitude. That's the extrinsic perspective, trying to use the tools of science, which has been so powerful, and then since Galileo has been sort of moved away from the subject because we want to be objective, of course. And then ultimately, you also need to explain consciousness in a unified view of the world, and that has proven so far impossible. Now, let's see if I can. It would be nice if this thing didn't freeze. Maybe now. All right. This is a slide I often show. You may have seen it before. This is just Leibniz, a great philosopher, that more than 300 years ago recognized this very problem, but it's now called the hard problem. He said, you can look into the machine. He was thinking about simpler machines at the time, as much as you want. What you're going to find is gears and pulleys and wheels and who knows what. Now we would say electrochemical stuff. You name it, whatever you think is really important, computations being performed. And yet you will not be able to understand, he said perception, but he really meant experience, consciousness. Okay, so that's what he saw very clearly then. Try again, I can talk. So he saw that issue, and I think we are still stuck with that. With most people, even if they sometimes say we need to take phenomenology seriously, that for a long time they didn't, are still thinking it's going to be some computational function about that. IAT takes the opposite perspective. You've been told that, you've read that. I want to make sure that seeps through very clearly. Okay. It really, in the end, this whole story is about ontology. It's about what exists. And consciousness is about what exists. So I want to just say that because you understand that at least from the intrinsic perspective, from the starting point of IIT, we are not trying to find this cherry on the cake. We are really reversing everything and saying consciousness, I like to say, is the only thing you have. In fact, it's the only thing there is. If we take that away, there is nothing left whatsoever. Now, anybody disagrees with that. If I take away your consciousness, there is something left in a fundamental sense. Anybody disagree with that? Well, right. Okay, so obviously your colleague there is not crazy. And in fact, it was natural to think that maybe I'm crazy in saying that. But I really want to insist on that, okay? So when you are gone, I suppose that you would agree on that. As far as you're concerned, there is nothing at all. If I hit you on the head, yes, as far as you're concerned. But yes, and would it be okay to continue like that as far as you're concerned? It would be. Oh yeah, it's okay in the sense that you're not going to feel any pain or loss. I grant you that. But if I were to say now, we're going to make you continue existing for everybody else in this room, but you're gone inside, would that be okay? Right. Okay, good. I'm glad to hear that. So this may sound silly at first, but it is not silly. It's the fundamental thing. This is why consciousness is so hard. Okay. It is really all we have and all we are. I like to say it's the only existence worth having, or more precisely, worth being. If you didn't exist in the conscious sense, if there weren't something it is like to be you, to use the famous sentence, okay, of Nagel and before him, really, there would be nothing in a fundamental sense. You can go on with the experiment, say, if everybody in this room, everybody in Osaka, everybody in the world, okay, were to disappear, meaning they all fall asleep, deeply asleep, okay, animals too, do that thought experiment, what would the universe be like, okay? Would it be worth existing as such a universe? And if you think a little bit about that, the answer should be no. We all have this mental picture that we developed at school, okay, and before school as naive realists, that, you know, I may fall asleep, my bed is still there, the room is still there, everything is still there. So we have this view from nowhere, so to speak, in which there is a universe that goes on largely unchanged, whether we are there or not. That's a good picture in one sense, but in another sense, is fundamentally misplaced. If we weren't there at all, the only fundamental sense in which something truly exists, which is for itself, would be gone. If you go on with that thought experiment, this universe as a whole, in which all conscious beings, seriously conscious like us, had disappeared or were deeply anesthetized, whatever you want, okay? Would there be something it is like to be the sun? Probably not, you would agree. Would there be something it is like to be a mountain or the sea, a rock or a table? No. Okay, we all have the intuition, no, and that's probably a correct intuition, as we will see. If everything were like that, what kind of existence would that be without consciousness? So suddenly, you should at least imagine for a moment that if we want to call that thing existence, the universe without conscious beings, it would something that doesn't exist for itself, and there would not even be anybody for whom it would exist. So to me, that's not an existence worth being and worth having, okay? And so when Galileo removed the conscious observer from nature, so to speak, to say, let us study things independent of this ugly thing, the subject who messes up things all the time, okay? He was fighting against Aristotelian science, so he might have been justified. He actually eliminated the only thing that truly exists in the universe, the conscious subject. Of course, he was not silly. In fact, he was the guy who actually very much coined the distinction between primary and secondary quality. So he knew what he was talking about. He did it operationally, and he was right and immensely successful. But I want today to start with this little plea to taking experience seriously, not just like, well, on top of everything else, there is experience and we should actually be serious about it and not just take a purely behaviorist approach. Seriously means it's the only thing there is, the only thing worth having, in a very profound sense. That's what IIT does by taking the intrinsic perspective. The intrinsic perspective, you start from your standard slide we always use. You wake up from nowhere. Let's say you were in dreamless sleep. Suddenly there is something. What there is experience, which is conscious. Okay? You're having an experience, say, of your body on your bed in your room for a moment. Even before memories rush in and they tell you what you need to do today or what you forgot to do or all kinds of problems you might have, there is something, and that something is experience. That truly exists, okay? It's the only thing. that truly exist. So yeah.
Sorry, but why should it be one or the other? I understand that if we believe we are actually sentient being with a consciousness and something, for our personal experience, consciousness is the only thing. Because somehow, again, this is really not my field. I'm a mathematician after all. But I miss to see why this invalidates the existence of the universe on its own. I don't feel as important to say that if I don't exist, then the universe stops existing. Even if every conscious being in the universe goes away, the universe does goes on. I mean, I don't feel my importance diminished. I also not sure my universe gets more important if I exist. I feel like just two different things somehow that can coexist. I don't know if it's.
Yeah, it's clear, and we'll get further. Let me just say for the moment, it's not at all about you, although it's all about you in other sense. Okay, so the thought experiment wasn't so much that of saying, if I'm gone, will the universe continue to go on, which it will in the way we all understand. It is, if we were all gone, presumably, okay, what kind of universe would that be if there were no conscious being whatsoever? What kind of existence would that be? Okay, can you imagine? Because we still have this God's eye view that if we're all gone, the sun will still be there doing what it does, the earth will still be there, etc. But would there be really a sun and an earth in any meaningful sense if there were no conscious being? One more question and then move on.
But there's no argument about why our imaginability coincide with existence of the external world, right? There's no argument. It's just an assumption.
Assumption about what?
About what you said. There's no argument, right? You just assume so, right?
No, the argument is, and that's why, and this is certainly not a new idea, it says experience exists immediately and irrefutably. So that your own experience, what you're seeing and hearing when you wake up and so on and so forth, exists. That is immediate. You don't have to derive it. It's not a derivation or an inference. And it is irrefutable. You can do anything you want, but you cannot deny that that exists. That was, of course, was Descartes' argument. Okay, so it's not a new argument. Before that, it was Saint Augustine who said that. It is a fundamental truth, if there is one, that experience exists. The only one you cannot deny. You can be skeptical about everything else, but not about that. That was his argument. And I'm just saying that's the kind of existence, it's immediate and irrefutable, that not only is there immediately and irrefutably, but I also want to say it's the only existence worth having or being, in the sense that if there is no consciousness, the rest, we might have this notion about the universe continuing, but if there's nobody there to experience anything, it is at least a very different kind of existence. Let's not get stuck on the word, okay? It doesn't exist for anybody. So what kind of existence? Okay. IAT actually is not dualistic at all. It is attempting to go for a unified view of nature in which we can explain everything from consciousness to the so-called physical world in the same way. And it doesn't at all deny that there is a so-called physical world and we should study it and we can study it and make lots of predictions about it, etc. Of course not. But unlike the approach from the extrinsic perspective, in which you try to explain consciousness after explaining all kinds of things about the behavior of mass and charge and spin, and you never get there because somehow it seems to be a radically different kind of thing, if you start from consciousness, I will argue, you can in principle try to get to a unified view of nature. Okay. Now, let me just say another thing here. There are many things that are anyway difficult to understand, and we'll go back to. That's the whole idea about having days to discuss these things. Physical in IAT has a very precise sense, and it's a purely operational sense. So by physical, we mean stuff that you can observe and manipulate. Going back to the original root of the term, observe with your eyes, stuff you can see, and manipulate with your hands, stuff you can play around with. And so that is, of course, how we learn about the world. When you are born and you play around with your hands and so on and so forth, and you do grasping and all those things, you see and you touch, and you get to learn about stuff around you, including starting with your body. Okay. In IIT, everything physical is purely operational. We do not have to assume that there is some intrinsic property like mass that has its own things as decreed by God, and there are laws of nature also decreed by God, that things must follow, and so on and so forth. We're trying to talk about physical as stuff that ultimately, as a conscious being, I can observe and manipulate. That's all there is to it. Yes.
So if we're starting from consciousness, I can observe and manipulate a mental image, but I don't know if that's what you would consider physical.
Yeah, we will get there. So
Okay.
words are always problematic. I can manipulate a ghost in my mind. What am I doing? Let's leave that. I'm just talking first, like literally about I can observe this and I can manipulate that. Okay. And then it becomes I can observe using calcium imaging and of individual neurons, and I can manipulate using optogenetics. So it becomes more sophisticated. Okay. But it's still starting from my eyes and my hands. Okay. And here, I just one thing. Let me just very briefly say a couple of things that are also mentioned in the paper that you saw, IT 4.0. But there are some assumptions that we make to proceed, just to indicate that IT is not crazy. Okay. So once you are a conscious being, and you have this immediate, irrefutable notion that there is something, and that something is experience, what you're conscious of right now. Okay. Period. For now. But there are lots of regularities in what you experience. So you close your eyes, and you open your eyes, and your body is still there, your bed is still there, and you do it 10 times, same thing. Okay, fine. So there is something that is very regular, to say the obvious. And so we take a realistic position, we all do, generally speaking, so that there is stuff, whatever it is, that exists independent of my experience. That would be also to you, okay? The universe, whatever you want to call it, there is stuff that's independent of my experience, because that explains the regularities of my experience much better than if I didn't make that assumption. So solipsism, the notion that all that exists is your experience, is a completely silly notion, because it explains absolutely nothing. It's notoriously not possible to prove solipsism is wrong, but it, as an explanatory hypothesis, is ridiculous. It explains absolutely nothing, starting with regularities that have to do with what's out there. Yeah.
So I might miss some points, but I want to make it clear. Where is the consciousness? It's only in our body or brain, or in environment, or both. Where is it?
Ultimately both, but the one I'm talking about now is in the environment. So I touch this and it makes a sound. I touch this and makes a sound. I touch this and makes a sound. So there is something there that must explain this regularity, okay? Ultimately, the regularity is something I observe as a conscious being, but it's regularity having to do with stuff in the world, okay? Physicalism is now more precisely expressed as something that can take and make a difference, or as we like to say, has cause-effect power. So I can do these perturbations or manipulations, interventions, call them whatever you want, and I can observe some effects, and I even measure the frequency of occurrence of these effects. And ultimately, that can be captured by a transition probability matrix, if you want to be a little bit mathematical about it. So if I do this many times, I see that with a certain probability. And so imagine doing that systematically and having a very good model. So you collect tons of manipulations and tons of observations, and you create some kind of causal model, which is expressed ultimately by this transition probability matrix. And finally, another thing that IIT does is to assume atomism. So it actually says operationally, while clearly we are never, or probably never, down to the smallest things that we can observe and manipulate, because we don't have the tools, we don't have an atomic hand and atomic eye yet, we should ideally strive to do that. Ideally, you have a better understanding of this giant TPM of the universe that you try to explain, if you could go down to the smallest possible units that you can manipulate and observe. And that's because you would leave nothing out, okay? In reality, we are dealing with these intermediate levels and we don't really know where the bottom is, okay? Something like that. So it's very, this is very consistent in a way with what we do as scientists, for instance. There is stuff out there. We treat it operationally. We don't attribute them intrinsic properties or powers of any sort. Ultimately, it's a giant TPM. And ultimately, it's a giant TPM where the units are the smallest one you can play around. Okay, that's sort of the assumption. Yeah. Oh. Okay. So, and as I said, we basically start from there, and I put the card there to remind ourselves that that's not a new idea, although he was using it in a different context, okay? He wanted something that would be a grounding for epistemology, from our ability to know things. IT has that as a grounding for ontology, for what exists, consciousness exists, okay? And then we are making these assumptions about the world, and we are using this operational approach, cause effect power, take and make a difference. And for obvious reasons, I'm going to use this flat brain here, sitting there with neurons, some on in red and some off, as what I can observe and manipulate with the tools of neuroscience, say, okay? And it's put in 2D for a reason. This we call a substrate, which simply means what you can observe and manipulate, like neurons. And you can turn them on and off, something like that, or more sophisticated things. Ultimately, when we try to understand the brain, what we would like to have is a good causal model of the substrate. So we could express this like some kind of causal diagram of some sort, but more precisely, it would be a transition polarity matrix, a giant transition polarity matrix, where you would ideally know everything that happens, whatever you do to the brain, you would see that the brain does X. And then, of course, you connect it to behavior and all the rest. So that's what we are playing with as neuroscientists, but keep in mind it's operation. And so the strategy of IIT is we don't just say consciousness exists, my consciousness, to be precise, exists for sure. And I make all these assumptions, and now where do we go from there? Well, we have nowhere to go. Now, IIT actually says, if you focus on what we call the essential properties of experience, that is those that are true of every conceivable experience, which he calls the axioms of experience, we actually can go very far once we formulate those properties in physical, that is to say, operational terms. And so the properties are these five, if IIT is right, okay? This has been a very, very long quest, started a long time ago, to try to identify within every possible experience that I might have, and I suppose the same is probably true for you, what is always true and cannot possibly not be true of an experience, the essential properties, and what instead is, a classical term is accidental. That is true of some experiences, but not of others. So to say the obvious, that this is white, the background, is an accidental property. It could be blue or anything else, or it could be not a screen, but a tree. But these five properties are true of every conceivable experience. And these are, that every experience is intrinsic, specific, unitary, definite, and structured. And of course, structured is the one that matters the most, in a way, in this context, in the context of this school, because that's what we're going to talk about a lot. But you need to understand that that's one of the properties, and not the only one, although it's the one that's critical for the quality of experience, as we will see, for the way it feels, okay? And so the idea then is, in addition to existence, with operational is perturbation and observation, manipulation, what you want, we want to translate these properties, because IIT says, if these are the properties of existence, the only existence worth having, worth being, and that's consciousness, and I can identify those, then when we go and try to validate the theory, it should be that the physical substrate, stuff we can observe and manipulate, of consciousness should satisfy those properties. in physical terms. So the whole idea is to translate or formulate those properties in operational terms so we can test it on the substrate and see whether it holds. If it folds, many things fall, okay? And so the idea is first, with the first four properties, you're going to find what we call a main complex, which is among all the neurons in the brain, or all the cells in the body, or all the atoms in the body, whatever you want. Which one is the set that is supporting, is the substrate for your consciousness, okay? And that idea says is called the main complex. It satisfies those four properties. We'll see that, okay, how we sort of do that. And it's called the main complex because we assume there is a big one in the brain, and it satisfies this property by being maximally irreducible as measured by phi, this quantity that measures existence in the sense of irreducibility. And once you find the complex, what you do is you unfold it. You'll see what that means. That is, you unfold its causal structure, its full cause-effect power, that of all its subsets, in a way that, you know, yields what we call causal distinctions and causal relations that are really meant to account for as an explanation for phenomenal distinctions and phenomenal relations. So very crudely put, phenomenal distinctions is whatever you can distinguish in the experience you're having. And we're not very good at that, but at least distinguishing things like this is my hand, this is my body, this is my bed, this is the left side of space, this is the top of space. All of this we can sort of say, and therefore attend to and distinguish when we talk about it. And then relations, well, my hand is on the book is blue, the hand is also on the body is on the bed is in the room is the left and the right side, the left is near the right, and all those things. So we will never enumerate all the possible distinctions from any given experience, and we will certainly never enumerate all the possible phenomenal relations. We just have them. But it's a starting point. We use introspection as a tool to bootstrap our intuition about the structure of experience. And we'll see, and I know you have already talked a bit about that, we decided to actually then start from the experience of space, of extendedness, and then time, of flow, temporal flow, rather than, for instance, from the blueness of blue to understand, can we account for the properties of experience? Because the blueness of blue is much more difficult to dissect introspectively, if possible at all. You can only do by comparison, not by dissecting it. But space, as we will see, you can actually dissect. So in any case, that's sort of the idea. And it's also very important to look at that with no additional ingredients. So IAT says that if those five properties properly translated in physical operational terms and then applied to whatever it is that is the subset of consciousness, we should satisfy those properties. Should account for not only if you're conscious or not, what the subset is, and how, for instance, consciousness goes away with deep sleep or anesthesia, et cetera, but also for the quality, for exactly how it feels in principle, with no additional ingredients. So once we have the TPM of the appropriate substrate, you unfold it. It's difficult to do, I grant you. That's why it's good to have mathematicians around. But then you don't need extra ingredients. You don't need some special force, some special energy, some special physical property. It's all this structural approach, where the structure is structure of cause-effect power. Okay, that's the claim. And finally, you can also measure the quantity of consciousness by summing up the amount of structure there is. Again, structure of cause-effect power, and the quantity there, we call it big phi. It is the sum of irreducible existence that exists within one giant structure called cause-effect structure or phi structure, which is what IIT says is identical in physical terms to the experience you're having. Okay, let me go back to this because this is also important. This is a key theme of IIT. It says that all quality, doesn't matter whether it's space or time or objects or color or nausea, all quality ultimately, if IIT is right, is a particular kind of structure. And the structure is purely to be derived from the TPM from if I do this, I see that with a certain probability by applying the postulates, that is the requirements of IT, nothing else, no additional ingredients, okay? Now, let's go through a little bit, assuming that that's the right thing to do, Matteo told me it is, and give a little bit of a sense of how this goes. I really want to point everyone to the IT 4.0 paper and to the wiki that you heard about to go and work out exactly how it's done in simple examples. But just to give sort of the idea behind this in broad terms, in essence, ideally, and one of the things I should say right away that we've done forever, but is typically not done, is forever, we started with simple models, say logic gates, but ultimately basically TPMs, okay? In which we assume that we know everything. So it's not like in neuroscience where you're trying to figure out exactly how the system is wired and how neurons interact and how that changes, which is very complicated. We're assuming that with these little systems, we know everything. We know the full micro TPM. So anything you need to know is there. And now we try to find the main complex and unfold the structure. So there is no unknown here, okay? There's only a computational problem, but there is no unknown. That, of course, is an approximation. For the brain, there are plenty of unknowns, of course. Not to mention, we get to that, the grain at which we should choose your units and the update grain and the states that matter and so on. So all of those are things that are addressed in IT, but they are critical. But here, we're down at the micro level. We have this thing, the TPM, there's nothing else. It's even an isolated universe of a few units. Here, these units are just 6, for instance. And we are just plotting them on the brain for the sake of it. But it's essentially as if we had a perfect causal model of this mini universe, and that's all there is, okay? Expressed by a transition probability matrix where you can see essentially all the input states. You can initialize the system in all possible states. So it's an interventional probability that you get. And you observe the probabilities of the output states for this whole system. More specifically, you can do it here with individual units. So for instance, you're a neuroscientist. In this case, it would be more like an electrician going in your little circuit that you built, okay? And you go in and you wiggle unit B, for instance, intervention, and you observe how that changes the probability of unit C, for instance, being on or off. Capital is on by convention, and the lowercase is off. These states don't mean anything. They're just two different states, okay? And you can measure these probabilities, and you can see what difference unit B being on makes to unit C. So it makes it very likely that unit C is off. That would be an experiment you could do, okay, an intervention experiment. But you also can ask, what is on the cosine of unit B, okay? Well, A is very much on the cosine. Depending on what A is like, it's likely that B's current B is going to be on or off. So you do that, you do this systematically. Essentially, you work out your TPM and look at now how it's expressed there. I'm doing it in a condensed manner. We are starting from what IT calls the 0th axiom, which is what I told you before. Experience exists. It's the only thing that immediately irrefutably is true. You wake up and there is something rather than nothing, okay? Translated, because operationally we define physical existence in terms of having cause-effect power. So the subset of consciousness, stuff you can manipulate and observe, must have cause-effect power, must exist in a physical sense, make and take a difference. And that basically this means that there should be some probability that differs from chance. That if you do something and you observe something, there is something happening that differs from chance. Then you can say there is cause-effect power physically, there is physical existence of some sort. Now we are going to go through, as quickly as we can, with the 5 other essential properties of experience. I'll briefly say what they are and then how they can be formulated in physical terms. So this is really a fundamental one. They all are, of course, by definition, but this one is the one that people usually forget. So experience is intrinsic, it's for the experiencer. Okay, it doesn't make any sense to talk about the experience I'm having is her experience. If you try to deny that, you confirm it. Okay, that's the same as for Descartes and experience exists, the cogito evolution. Okay, so experience exists. People often say from the first person perspective, or it is private, or people use all kinds of words because words are difficult to use to say these very, very basic things. But all that means is the experience is for you, where the you doesn't have to have a name, doesn't have to have a history attached. You can wake up without yet being aware of your name or your history. There just is something. And when you are under certain, drugs, I mentioned this morning 5-MeO DMT, or some deep meditative states, you may indeed have pure experience with no self, no thoughts, no objects, but there is something it is like to be, okay? So that experience is always, so to speak, from the inside. And that's what we mean by intrinsic. Translated here in operational terms is very easy in some sense. All you do is you put a border here dashed around some of the units of your substrate, for instance, 4 out of 6 here. Of course, it would be a bunch of units in your brain against the rest of the universe, but let's just do it here. And you call that a candidate substrate. You say, what about these 4 units here? Everything else is called a background condition. Whatever is inside is what you consider to be the candidate substrate for consciousness. It must not only have cause-effect power, which we already checked, it can take and make a difference, but it must have cause-effect power upon itself. That's what intrinsicality means, given some background conditions. So this is now illustrated on the TPM, in which we fix at T0, really, so to speak, the background condition. This is how the universe is around it. And then you actually see, does that system with those background conditions now still exert cause-effect power upon itself? If the answer is yes, it means it can take and make a difference to itself, then it satisfies intrinsicality, okay? A chain feed forward would not, okay? The next property is experience is specific. It's called information that leads to lots of confusion. Nevertheless, I think is correct. And what it says in the axiom, it is specific, is this one. Now, there are 2 ways to think about this. There's a simple way, which is the experience I'm having right now, say, is this, or whatever you're having now, and is not, indicated here, any of a giant number of other possible experiences that I could have had, but I'm not having. So everybody understands that, yes, every experience then is specific. It's this one and not any of the others, okay? And that's a property we call differentiation. And it's important, especially from a mathematical point of view, but really the axiom is more precise than that. It just says the experience is this one, period. It doesn't even know whether other experiences are possible or not. Right now, it's this one, okay? And you cannot deny that. It's not that one, because then it would be that one and not this one, and so on and so forth. Again, I won't spend time in discussing the axiom in any detail, because otherwise we'll never go through where we want to go. But that's the basic idea. So it's this one. And I want to take this opportunity to say again that one of the biggest problems about the axioms of IIT is precisely that these properties that they highlight, the essential property of every experience, are so obvious that people don't see them for what they are. They are properties of existence. There is no way to have an experience that is not this one. It just makes no sense. You can't even say it's absurd. Well, that's exactly the point. But once you recognize that, it's far from trivial in its consequences, as we will see, okay? So it's this one. Translated here, it means that the system must not only have cause-effect power, not only upon itself, we're still using this candidate system, of course we could choose anyone, but we're choosing this one, but it also must specify a particular cause and effect, a specific cause and effect, okay? And the way it's done basically is we consider the system in its current state is not an average, it's not some kind of ensemble of possible states, no. It's its current state, for instance, neuron on and off, let's say, this guy on, those 3 guys off, and then you ask about its cause and its effect, given the way it is now. So you must pick, choose, specify which one it is. And so suddenly, from this TPM, given the background condition, we must choose the particular cause state here in red and the particular effect state here in green, that the system, one way to think about this, thinks is its cause and thinks its effect. Of course, it doesn't think anything. It has power and it must pick a cause and an effect given the state it is in. That's how you get this one. And so this is done here. And you can see that it picks this particular cause state. So A off, B on, C off, D off, given that it is in state A on, B off, C off, D off. And it picks that particular effect state, A, B off, C on, D off, with a certain, they have high probability, as you can see. But really the way to measure that is to this intrinsic information that is indicated here, okay? And has two terms. Again, we can get to that, maybe informativeness and selectivity, but that's basically a way for the system to choose of all possible cause and effect state within itself, these are all within, okay, the ones that it should select. Yes.
Just to see if I get it right. And I do have that 0.82 and that 0.84 in that matrix because this is intrinsic.
Sorry, I didn't hear the beginning.
I have this 0.82 and 0.84 in this matrix
yeah.
because this is intrinsic.
Yeah. So the rest is fixed, and then the background dictionary percolate forward and backward, but here we are at the micro level. Given the background, my intrinsic powers say that those are the probabilities. And then based on those probabilities and that formula, I won't go there now. The formula tells you the intrinsic information for every one of these possible causes and effects. But the one we pick is the maximum, the one that maximizes this quantity. And that maximum is based on one of the, I didn't show the slide, the 4 principles of IAT: maximal existence, minimal existence, being, and becoming. We'll get to that maybe, but I just, that's roughly how we do that. We pick the one that is most specific, okay?
What was it? This 8.82 could be outside of the matrix, but then the system would not be intrinsic.
Yeah, this has to be inside.
Yeah,
Absolutely. Okay. The next property, which has been remarked upon by philosophers at least, is that experience is unitary. Every experience you have is one, and you cannot subdivide into independent components. You experience the full visual field, is my standard example. You don't experience half of it, and then another half. Then there would be two people experiencing half of the visual field. It's always one, and so on and so forth. Okay, you don't experience the book without its color and so on. So it's always unitary. Kant saw that, Descartes saw that, many people saw that, okay? Aquinas saw that. These days, people are a bit confused about the term integration, but nevertheless, let's say that this is a property that I hope you can all agree once we understand that integrator means having one experience, okay? You cannot separate it into pieces. How do you translate that? Well, this is the way we do it, but basically, we take again this candidate system, but this time we ask not just what state does it pick, but we ask whether it picks that state, that cause and that effect, as one system, as a whole. So you see, it is unitary, it is a whole, irreducible to separate experiences. Cause effect power must be unitary. It must specify a cause effect state, that information, as a whole, irreducible to separate subsets. And the way we do that is we cut, essentially. Do the equivalent of cutting in all kinds of ways. You have to normalize property, et cetera, you'll find this in the papers. But in essence, you find the weakest link in the system. You find that the cut, the cruelest cut, if you wish, the one that makes the least difference to the system, because no system can be more integrated than it is across its weakest link, once you know how to properly use that. And that's based on IIT's principle of minimal existence. At any rate, you measure this quantity, which you see is very similar to what you saw for intrinsic information, except now, instead of unconstrained, is partitioned. So you compare the probabilities when you have the causal interactions, the connections available versus when you cut them, okay, you noise them, so to speak. And then you find out to what extent this is one thing. Of course, if these were two completely causally independent sets of units A, B, and C, D, phi would be 0. That's the quantity that measures that. Okay, so it's not 0. In this case, it's 1.32. Once again, you measure this on the cos side and on the effect side. And again, based on the principle of minimal existence, you cannot be more integrated than the least you can be. You pick the cos side, which is the least. And so phi for this system in that state is 1.32. And finally, before we go to structure, there is the axiom of exclusion that is usually the one that's least understood of IIT, or sounds strange maybe. It says that experience is definite, which is expressed there as it is this whole. So indicated there in the figure, what you experience is not just this and not only the left side, etc., separate from the right, but actually you don't experience the left side only. Your experience contains, so to speak, is the content, the left and the right, the top and the bottom, the body and the bed and the room. It contains all of those things, not less than it contains. It's obvious. It also doesn't contain more than it contains. Visually, so to speak, it doesn't extend beyond your back, obviously. Okay. But the key point, which is again true of every conceivable experience, is that it contains all it contains, not less and not more. Again, you can see why this sounds sort of almost trivial to say that. It contains what it contains. Yeah, but that's actually a fundamental thing. There must be a reason why it contains that, and it doesn't expand to contain the universe, so to speak, experiencing all the thoughts of all the inhabitants of Osaka right now. Mine doesn't do that. And I doubt that even people who have mystical experiences will experience all the thoughts of all the inhabitants of Osaka, and not to mention animals and plants. So it is definite. How do you translate that? So now I gave you ABCD as a candidate subset that satisfies the various properties. This last property is indicated like that. You must specify this whole. You need to pick, is it this, the subset, ABCD? Is it less than this? Is it more than this? Is it a piece in and a piece out? Subset, a superset, a paraset? So there must be a reason why. And again, based on maximal existence, I won't go through it. What you end up doing, just like for picking the state, you pick the substrate whose phi value, whose irreducibility, quantity of existence, is maximum. So you compare ABCD to any subset, ABC, D alone, AB, ABCDO, ABCD over J, or 6 of them. You try, ideally, all of them. You measure their phi, how irreducible they are, if they were the complex, and you find those units that together are maximally irreducible. That is, they exist the most intrinsically, specifically, unitarily with that border. Okay. There's also an issue about the grain. What is the grain? But let's leave it aside. And in this particular case, of course, that's why we illustrate like that. The set that has maximum phi is ABCD in that state. So you call that the main complex. And the way IIT goes is recursively. So if you take any subset, this is only 6 units. If this is the main complex, the one with maximum phi, then you're left with 2 units. And there are only 2 possibilities at that point. They might form another complex together, but they cannot overlap. Or they might form 2 separate complexes, which in this case we call monads, so the smallest entities you can have. Yes.
Sorry, you did say that this is the most, or one of the most difficult to understand axioms. And I just wanted to check what the difference is, or why you specify this exclusion axiom in addition to this information axiom, where the information axiom was the experience is this.
Yes.
But here then you have the experience is this and then whole.
Yes.
So why is it that you specifically add this whole, and why is it not the same as the information axiom?
Yeah. Well, in fact, the wording is very carefully chosen. Believe me, we spend a lot of time to try the most concise way of expressing it. But in one case, information, he says, is this one, sort of among a repertoire of possible experiences, if you wish, okay? And in the other case, we say this whole, among a repertoire of possible wholes. So literally, it's easier to see this on, if you wish, the operational side. In one case, you pick the state. In the other case, you pick the substrate. whose states you pick with information. Okay, so there is very easy. One is which state, which cause and which effect, and the other one is over what subject. Okay, and but in essence, you know, you could, in terms of phenomenology, you could, for instance, imagine that this whole is your visual field, and you may have tons of different pictures showing up in your visual field. And then it would be this experience and not that, this experience and not that, and so on and so forth. That's the specific. Or you may have surgery. We remove half of your occipital cortex. And now, and this is a fact, suddenly, as far as you're concerned, there's no problem. You have shrunk, but you don't know that. Now, suddenly, what exists for you, your experience, is half the visual field that you had before. But you actually don't know it. That's one of the beautiful things. Just like we don't know that our visual field has a border, is definite right now, it doesn't seem to end anywhere, because if it did, we would see what's outside the border, and so we would experience it, okay? But it doesn't end anywhere. So we don't know that we are sort of limited, but we are. You have to think about it and realize, well, I bet, you know, I must be. I'm not experiencing everything else in the world, okay? But when they cut off half of your brain, then everything indicates, but there's a beautiful experiment that shows that only one in one patient, everything shrinks, but you don't know that. That's what exists, and it's perfectly fine. You're full. But not less than that. Half of that, you know, would be a problem. Okay, so now,
just a quick question. So my understanding is that compared to the integration axiom, exclusion basically emphasized the boundaries of
I call it the border, but
the
yes,
border
yeah.
experience.
Yes.
Thank
Yes.
you.
So one says it has to be integrated. And the other one says, well, what has to be integrated? This. Okay. And because experience has a border, so to speak, a border you don't see, but it obviously contains what it contains, and not less and not more, so must the substrate. But, you know, in the brain, for instance, that leads to very important predictions, okay? In the brain is all interconnected. So there is no way that we would find out the brain as a whole is not integrated. In fact, it's integrated with the body, okay? There are obviously interactions among the brain, the body, and for that matter, the body and the environment, almost at any moment. So integration, to some extent, is ubiquitous. But IIT say, well, it's not enough to be integrated. If you're not integrated, you don't exist as one entity, no doubt. But you have a border, and that means you must have that and exactly that border contain exactly what it contains. And the answer to that is from first principles again. Then I will enunciate that principle. The principle of maximal existence says, among possible existence, the one that actually exists is the one that exists the most. That's one way to put it. So now it's all about existence. Consciousness is existence, the only one worth having or worth being. And I'm just saying, so the point here is there is essentially, let me go back to that, a competition for existence. This thing could exist to the tune of 1.32. That's its quantity of irreducible existence, because if it is not irreducible, it's not existence. These other guys, A, B, C only, could also exist, and we can measure its phi, and its phi is 0.01. Or a bigger system, this giant one here with 6 units, but it's also integrated, not very much here, but it is. Its phi is 0.05. Okay, so all these three are sort of vying, competing for existence, but because my experience is definite, it's not, you know, shrinking to a point or expanding to the universe. It's what it is with its borders. Okay, there must be a reason why it should be this rather than that or that, and the reason is given by maximal existence. That's why it's self-consistent. So we'll try to, yeah, there was a question, and when do we need to finish? Because I want to at least introduce the composition. Can we do that? Yeah.
I'll be quick. So this might be a naive question. So I was wondering, what about cases of dissociative identity disorder or like polycephaly, I think, when people are born with like two heads? How does that fit into the integration axiom? And or would you call those separate experiences? Because
the body is not the constraint?
So that's a long story and an interesting one because we need to distinguish. I just mentioned two things. Maybe we discuss this in the afternoon. So one thing is the so-called dissociative identity disorder. And the typical manifestation of that, which is complicated in psychiatry because there have been few true cases and many sort of pseudo cases, but are actually one in which there is one typically personality that dominates. And when that dominates, the other does not, or at least it seems not to. And so that needs to be ascertained, is that really true? But the perfect case we always had in the past, 80 years or so is the split brain case. So this is a case in which it's not psychiatric. So we sort of know, we cut the callosum, if you cut it all, or if you cut the posterior part, and the posterior comes through, that's what matters. Then you literally seem to have two parallel entities that exist, each of which is unaware of the other guy. Okay, and that's what has been shown in time. There have been some controversies lately, but basically I think that's the right story. Okay, and so IIT would say, the behavior may be seemingly integrated, but the whole point of Sperry and Gazzaniga when they did those experiments was to show that actually the experience, although they hated to talk that way in those days, was actually separate. There was one guy seeing the left side and one guy seeing the right side, and they didn't know about each other, as if there were two people. Okay, so I think in some psychiatric cases, there may be something like that too. And once with Shun Sazai, once we did an experiment with fMRI, where we tried to simulate that and get a functional split brain in which we're doing the typical thing people do, driving and listening. And sometimes you seem to be going on autopilot while driving, while listening to something interesting. And we show that there is sort of a breakdown a bit in something like phi when compared to when you are driving and listening, meaning that you're listening to instructions about where to turn, for instance. Okay, so there are many interesting experiments to do there, but the dissociative identity disorder is a difficult but very interesting one. However, we don't have data on that yet. Okay, all right. So last axiom and postulate. So the one most germane here is, as I say, that we'll use these words. Okay, every experience is structured. And structure is a broad term again. What does it mean? Well, I say there are things you can pick out or distinguish within the experience, introspection giving you a starting point, and these things are related. Now that's another term that's used in a terribly crude manner and vague manner. Things are related, okay? And again, in IIT, everything is going to be defined precisely and from the intrinsic perspective. But for our purposes right now, this means suddenly that once we have identified the main complex, which I showed you was A, B, C, D in that state, okay, the one that maximally exists. Now that we know this is one entity, we need to figure out the structure of the cause-effect power of that entity. And that means we are not simply asking what is its current state and the cause and the effect that it specifies, but we are asking for all subsets of that entity, the power set, starting from A, B, C, D, A, B, C, C, D, and all of those. Let's look at the cause effects of all those subsets within that system. So it's indicated here. This is the set of possible, we call them mechanism, units in a state. Okay, so we got A being on, B being off, and let's focus on C, C being off. Okay, so there is C being off. And that too must have a cause and an effect within the system. We apply exactly the same postulate requirements of IIT for the system to its subsets, except for composition, of course, because we are looking now at the structure. And so this guy turns out, by applying the postulate, says my cause is A off and my effect is D off. You just work it out, the same principle. And then you do it for all of them. And here, let's focus on this one. This is a third order mechanism, 3 units. And for those two, you can ask, what does BCD all off say? Well, it says my cause is AC off and my effect is ABD off. Could be anything else, but you work it out using integration, exclusion, etc. as usual, okay? There are some subtleties, like it has to be congruent with the state of the system, but leaving it at that, you do this for all of these guys. Some of these, like C and BCD and the others in black, will actually form these cause-effect pairs. We call them causal distinctions. So they are irreducible. And they have a phi value. how reducible that distinction is. My cause, my effect within the system, okay? Some of them, the ones here, don't, meaning you will see that their cause effects are reducible, so they don't exist in the same sense within the system, okay? They are not something that has a phi value, so they don't exist. These do. And once you figure out the ones that exist, you can also ask whether their causes and effects overlap. And that's literally what is indicated here. So you see A of is the cause of C, but AC is the cause of BCD. So the two causes, one a bit broader than the other, overlap over A. So there is an overlap in their cause. And there is also an overlap in the effect, because this is D and this is ABD. So these overlaps between causes and or effects we call causal relations. And like with everything else, we can measure how reducible they are, how much they exist within the system. And so they get a phi value too, a phi value for distinctions and a phi value for relations. And so if the distinction is indicated by these yellow lines, a relation is indicated, for instance, between two by an edge, like this edge. And then if it is a relation between three, like three causes, two effects and a cause and another cause and effect, then we show it as a plane. That's just a way to show it, okay, this plane here. So it's impossible usually to display all of this stuff properly, but the whole idea is within the system that's maximally reducible, so it is the subset of consciousness, we now work out its structure, its causal structure, by looking at all the reducible things that each of its mechanisms say about the system, cause and effect, and how these things they say overlap. And if you think about it intuitively, if within a system two effects overlap, so my effect overlaps with your effect, that is a causal statement. That says something about the fact that, you can use various metaphors, but if cause effects overlap over some unit within the system, then it means that for the system, there is some integration there. So something exists. It's different whether two effects don't overlap or two effects overlap in real life and in terms of cause-effect power. So that's why relations now are physical in the usual sense. They have a phi value, they're irreducible. They are not things we say. They're not extrinsic statements like I'm related to my brother, or that point is related to that point in space by having a distance among them. We'll get back to that. These are physical relations, precisely defined. They're irreducible and they have a value of phi associated with that. And so I will end with this slide, then we take a break. That's from a paper that's waiting to be published, because another paper is sort of coming to make it a little bit more obvious what it shows. But this is a paper done with Alireza Zamzadeh, comparing Shannon information and integrated information, and showing, you know, it's a way not to say anything wrong or bad about Shannon information, which is wonderful and elegant, but to highlight in which sense IT is different. It's intrinsic as opposed to extrinsic. It's causal, it's compositional. All of those properties, basically all the postulates of IT are true of integrated information. They are not true of Shannon information. And ultimately that's critical because that's where meaning lies. IT is about information as meaning. Shannon is about information as stuff you communicate. It's a longer discussion. I want to put in the context of the brain. The way most people in the cognitive neuroscience community talk about the brain, and I'm sure you've heard it, I'm sure you talk that way too usually, is it's an information processing device, some very sophisticated information processing device. There is information coming in from stimuli. There is contextual information coming in from other stimuli from the rest of the brain. There is predictive coding, there is, you name it, either feed forward or feedback. It's all information processing. So here the example was Alice, who is seeing a house on fire, and she texts Bob, house on fire, basically, and she's worried about the cat. Okay, that's one experience, just like that, the usual Alice and Bob, in a physical context. And you can try to explain that in terms of what the brain does and the information processing going in within the brain, okay? Stuff comes in, it gets decoded in various places by this complicated neural network, okay? So again, VLAM would be a very good example of that. There is all kind of context dependencies such that you have disambiguation top down or prediction and then correct, all the stuff that people talk about. You decode everything out of this. I'm sure you can decode it very well from lots of places in the brain. And then finally, the brain does X. If you had a good model, you would be able to predict what the brain does. And the story ends there. No need to bring in anybody seeing anything or worrying about anything. This is the machine doing its thing, okay? That's all in terms of information processing. And this encodes house, and this encodes fire, and this may encode the integration of house and fire, whatever that means, okay? IIT is radically different. The situation in her brain when she's looking at the house on fire and she's worried about the cat, there is a main complex. There's lots of additional little complexes that are worth little, almost nothing, I would say. We don't know that for sure, but it's likely. And sure, the processing is going on, meaning the machine does what it does. But what truly exists is this complex in that state unfolded with this giant structure that means house on fire, worried about the cat, with all kind of phenomenal distinction and phenomenal relations that correspond exactly, that's the identity of IIT, to causal distinction and causal relations. Of course, a very complicated structure, but the message I want to end now with is, according to IIT, this is the translation of the properties of the only existence worth having and being. What truly exists, if you had the right, I used to call it the qualia scope, something that immediately you point at the brain right now, at Alice's brain, and would show it unfolded, which is really what it is, would show this giant diamond, extraordinary structure of distinctions and relations, purely derived from the principles of what consciousness is, which is what existence is. And that is where all the meaning is. All meaning is intrinsic. I like to say the meaning is the feeling, okay? What it feels like is what it means, nothing else. And it's completely intrinsic, completely intrinsic. And that's what truly exists. But if you are taking the extrinsic perspective, all there is a substrate, a machine doing its job, and you can predict what it's going to do next. And that's all the reason you'll never find consciousness there. So let's stop here. Okay.
So this is about the previous slides where we had experience structure. Here in those sets, we had some elements that exist in the set but don't form cause-effect pairs. So what would that mean? Does it mean that they still exist as information in our brain but are unconscious? Or does it mean that they're not meaningful at all if we're looking at consciousness?
So when you say they exist as information, I have to stop you and say, you know, we need to know what you're talking about. Because my whole point is information is a difficult word used in all kinds of ways, in a way nobody knows what it means, except for Shan, who is very precise and very good. But when we use it loosely, we don't know. So the idea would be, let's put it more in a neurophysiological perspective. And let's use an example that I often use, although we don't know the final story about that. Let's take binocular rival, which now is an expert. So one of the possibilities that's envisioned by IT, this is one of the most interesting prediction, if you wish, in an area that's sort of well studied, is that you may go into the main complex. So let's go back here, okay. One, instead of this, let's say you're putting in some kind of rival stimulus. So one eye sees one thing, the other eye sees another thing, for instance, but you experience only one, at least for 2 seconds, and then it switches. But let's stick on the moment in which you experience only one. Let's not do continuous flux suppression, let's just do a more traditional rivalry situation. There is going to be, and we know that, lots of activity throughout posterior cortex, and you could decode, you actually definitely can decode, both the seen experienced stimulus and the one that's not experienced almost just as well. It's probably not just as well, but very well. You can certainly decode both, okay? And recent work in monkeys has shown, for instance, that you can actually, even with a single neuron, decode information, meaning decode stuff, about both stimuli in the firing of the same neuron. And there are also neurons that respond preferentially to the one that is not seen, okay? So those are facts. And then people can argue, it used to be said it was mostly in V1 were mixed, and then higher up it was not mixed, but actually it's mixed pretty high up. So in IAT, one prediction would be that all the neurons responding preferentially to the unseen stimulus that are actually firing right now, and all the neurons that are responding also to the unseen stimulus, but also to the seen one, okay? What you need to do is check the cause effects of the individual neurons or subset of neurons, because you have to do it for all possible subsets. And you're going to find that, for instance, there may be a neuron, or rather a subset of neurons, that is not forming a cause-effect pair, as you called it, that's irreducible. So then, even though you measure them and they are firing to this and that, they would not contribute to existence because they are irreducible, which is what you were saying. Okay. But more than that, there is also the possibility that it may actually, let's say one individual neuron responding to the unseen stimulus, let's say the unseen stimulus was, instead of a house, a face, a neuron responding to the face very beautifully. It says my cause is down here in V3 and my effect is up there in IT, say. And that would be irreducible. So it could exist within the system. But IIT says, based on principles I mentioned but didn't get into that, if the cause effect of that neuron that's saying I'm seeing this and I think my cause is that, my effect is that, is incongruent with what the main complex is saying, this is my cause and this is my effect. Literally congruent means I think this neuron was on or should have been on, and instead the system says that should have been off. That's what incongruent means. Then, while you can show that it would specify a distinction, that distinction is incongruent, so from the intrinsic perspective, it doesn't exist. So you can show it from the outside, and I think in rivalry, probably that's what happens. We could have this discussion, that things that overlap in space, space being critical in all of this, tend to be either one or the other. So if they are saying incongruent things about activity in V1, V2, etc., then one will win and the other will not, and it fits with IIT. It would say you'll find traces of it if you record from visual cortex. It just doesn't make it to experience because it's not part of the cause effect structure because of incongruence.
Hey, thank you for the great talk. Can you say what, in your opinion, are the main metaphysical or other problems IT is currently facing?
Can we leave that for later? Because I want
Yes.
to have the break, and
Right.
I love to talk about metaphysical problems, but
Sure.
Yeah, thank you for a great talk. I just had a question about the axiom of exclusion. So when you specified the specific property, you said that it must be in this state and select this cause-effect state. And for the unitary property, that it must specify its cause-effect state as a whole set of units. And I guess I don't see how the definite or the axiom of exclusion goes above and beyond that in any way. It seems to encompass both of those things. Yeah, so I'm just, I guess I'm just curious.
So think of it again, words are what they are, but one thing is what it contains in the sense of what's in the picture. So if you have, I gave the example of, if you have only one hemisphere, not two, what's in the picture is what is half of the normal visual field. And that's one sense in what's in the picture. That is, how big is the canvas? And the other sense is what's in the picture, and what picture is on the canvas, what's painted on the canvas. So the easiest way to think about, just to understand what we're talking about, is one is what's the canvas, and that's what exclusion deals with. And the other one is what's painted on the canvas. Okay, so the state is what's painted on the canvas, is a face, is a dog, is a tree, whatever. And the size of the canvas is what it contains. So the word what is ambiguous, okay? Because you look at the canvas and you say what's on the canvas, and then typically you speak about the content as if it were the specific things that are represented there. But instead, here, I'm trying to make it explicit. First, we need to say, what does my experience contain? Okay, it could contain less. So the best is to think It could contain less of your current visual field, but it doesn't. So it has nothing to do with what is it you're seeing right now in and of itself, in the sense that you're seeing me or so, but it is containing clearly the entirety of it and not half of it. So think of it that way. The exclusion is not half of it, it's not a quarter of it, it's not a few pieces, or it's not more than it. The information is, okay, yes, but what is that half, or whatever it is that you're seeing? Okay.
Hi, thank you for the talk. I wanted to a bit clarify like the general overview. So it seems to me that IIT kind of treats consciousness or experience in a sense as a transparent entity in a sense that it like maps directly to the structure that is realized by the brain, and there's like nothing in between. So it is in a sense like anti-psychological, that there is like nothing happening in between what we experience and how it is realized and whatever it is realized. So there is like a direct correspondence. So in that sense, we could technically just so in that sense, IIT is like coming from the directly from the experience is not technically necessary in the sense that if we had the technology, we could just observe what's happening in the brain for as long as we need to and as much detail as we need to, and we would like figure out eventually the same mechanisms that obviously it's easier from this theory to like first kind of restrict it as much as we can from our introspection, but in the sense we could go from the other way around, never get into the theory and just like observe the brain to an extent that we will figure out those relations either way because they are like so tightly coupled between each other.
I'll try to say a couple of things about this, but now I want to make sure that then we stop, we take a break, because if you want to have a break before we go into the next part, otherwise. Okay, but I mean, I need to have a sense of how long we are supposed to go, because I feel like we need to stop and have the next part about equality. Okay, so a couple of things. I don't know really what side you're coming from, but I would first just say, let's forget about the philosophical terminology about transparency, for instance, of experience. Okay, just forget it for a moment. Okay, just there's nothing there. It's a misnomer actually to think about its experience as transparent. It comes from some presupposition that I don't want to go into that in philosophy. So I also would like, if you are hinting at that, to completely ignore the distinction that's fashioned between vehicle and content. Okay, that's also typical in philosophy. Forget about that. So here, try to forget what you've read or learned and so on that they tell you about, because without understanding consciousness, most philosophical problems are sort of ill-posed, because it's the most important thing of all that they should start from. They don't, and therefore then you get stuck precisely where consciousness comes in, and what kind of problems arise from that. So I'm not sure, are you a philosopher? Okay, fine. So you inadvertently, that's perfect, you see, that's perfect. You brought up something that I hope some of the philosophers here, I saw them nodding, understood what I was saying, because you use some code words like transparency and then looking at the brain. But instead, the more important part of what you asked, let's try to make it clear, is if you were to look at the brain, okay? So you were saying, imagine, forget all this phenomenology starting from experience, we'll just work it out from looking at the brain and measuring it over a very long time in great detail, okay? What would you measure? So the whole point about this slide here is that if, which is what neuroscientists, including myself, all the time talk about when, oh, we need to understand how the brain works, want to know is, ideally, I want a full model of the brain. Okay, let's say you know all the connections, and imagine that you have little plasticity for a little while, so you can sort of keep it constant for a while. I know everything. I get the whole TPM, in essence, okay, of this thing, such that I can know what it's going to do next, and next, and next, and next, from any condition. So if you had that, you would have the ideal sort of understanding because you can predict anything the brain will do. And most people will say, if you can predict everything, that's it. What else is there in science, okay? In essence, that's a typical attitude. The functionalists might come in and say, that's too naive. We don't just want to be able to predict what it does, one thing after one thing after one thing. So we'll predict the states. That's good. That's critical. It means we understand something fundamental. We've got all the nitty-gritty worked out. But we also want to give a functional characterization of it. Say it's doing work in memory now, or something like that, okay? Or it's doing image recognition now. So we have this higher level cognitive operation that are implemented by the brain doing this. And then we really understand. So I would claim that most of our colleagues in neuroscience, psychology, cognitive psychology would be perfectly satisfied with at least these two levels. Some people will just say, yeah, just give me the machine, what it does, but then there's nothing else there. Most people, I think rightly, would say, no, wait, we have these additional levels that we need to characterize because otherwise we don't understand really what it does, okay? And they can be multiply realized and so on and so forth. So you need this additional level, which is this functional or computational level of description on top of the brain. Once you're done with that, that's the cherry on the cake that I was talking about at the very beginning, okay? You're left with, and then we have consciousness, my own, without which there's nothing at all, as far as I'm concerned, okay? How do I fit that in a mechanistic full understanding plus a functionalist full understanding of what it does? It seems to have no place for it. Then there's no reason to invoke it. It doesn't explain anything of that sort. And in fact, that's exactly how we treat VLAMs or LLMs. We can, it's sort of complicated to figure out exactly mechanistically how they work, but there's no mystery there. And yes, it's difficult to understand why they did that, but we're making great progress there. We can even ask them and they can give us some explanation that are a little bit like the ones we give now. So once you have that, what else is there, okay? There doesn't seem to be any need to bring up anything like consciousness. No reason whatsoever, except for the fact that that's all we have. And so we sort of need to put that and get a unified notion of nature in which, yes, there are brains and they do their things, and there are computers and they do their things, and there are functional descriptions, but where the hell is consciousness? We left it out. And so the typical way, either you deny the problem or you say it's insoluble, or you say things like, well, really consciousness after all cannot possibly do anything but some function. Global information broadcasting, high order, checking that how valid our inferences are, or things like that, okay? Or the depth of prediction, or things of that sort. That's what you find. The only solution you have, and then there is consciousness, which can only be possibly some function, this or that. One thing you wouldn't do, because I don't see why you would do that, is come up with, well, we need to take the TPM and not check what it does, which we already know if we have the TPM, but actually unfold if there is a main complex, what are its borders, what is its grain, what is its structure. All of that you only do because of the way consciousness is. I mean, that's how we ended up doing it if we are doing it right. Why would you do that if there's no reason for that, okay? So I don't know if it helps somebody, I don't know if it helps you, but.
So I just want to make sure that I understand correctly. So for the information processing, like let's get the visual input, that we had the visual input and we had like all of this activation across the brain, but for the integrated information, there's only like a part of the activation that corresponds to this one experience that we had at this moment. Yes?
Yes, but that's certainly not it. Meaning there's going to be some activity pattern over this part here that matters for consciousness, whereas these don't, only indirectly. Yes, but an activity pattern by itself means absolutely nothing. It's an activity pattern over this network. Once you unfold it, if it has all the right properties, it will feel like that. So what truly exists is this giant cause-effect structure. Is not the substrate, is not an activity pattern, is none of that. What truly exists is this, and this is the experience. But you're right that whatever is happening here does not contribute at all to the experience. That's a key prediction of IoT. Anything inside here that's congruent, etc., will contribute, will have to something to the experience, Everything outside will not.
So as someone who comes from a communication discipline, so Shannon's a big part of what we discuss, I'm curious how like noise and stochasticity would be interpreted in the integrated information theory. So sort of thinking about like, if you assume a Shannon environment and perhaps you could model everything, and so free will might not be, it might be debatable. And maybe noise or some randomness built into the system helps to bring free will. Does that play any role in integrated information theory?
Too many roles, but not to discuss now. So the free will story. So I know that you had the paper. I doubt that it percolated, and I have good reasons to doubt that. I will discuss that if I can tonight, okay? And I will bring in both the fact that noise in and of itself has nothing to do with free will, which is unlike what most people think. They think, oh, you know, determinism is bad, indeterminism maybe saving the day, but it doesn't. And many people have recognized that. It has nothing to do with that. It has to do with ontology, with what exists, with this. And I also talk, if we want, later a little bit about, because I only showed this final picture, okay, about what is the role of noise in IIT. Actually, at the fundamental level, IIT requires some indeterminism. In fact, ideally, we can work out the precise amount that's required at the micro level. It requires it, otherwise there is no cause-effect power. If you don't have a repertoire of possibilities that's always there, you cannot take and make a difference. But that's an interesting story for later. Okay.